morning children, good morning to all of you. And now today we have to discuss the same topic in the previous lecture. Now we have discussed about the combination of resistance, how can find out the equivalent resistance between the given 2 points in the different circuit diagram. Children, now we have to start from the example questions here. You see, the first question, there are the 3 resistance are given in the circuit diagram. One is the 3 ohm, 3 ohm and 3 ohm. In the place of 3 ohm, 3 ohm and 3 ohm, there the different resistance is also given to you in the question paper, but the procedure you have to follow and solve it. The different questions which is given in your different books have a different values. Okay, so now see the procedure, how can solve this type of question. And now first you find out the combination which is given in the circuit diagram. There are the 3 ohm, 3 ohm and 3 ohm resistance are joined in series or parallel, or any other concept is applied in these questions. So now see the first, you see the first resistance here, 3 ohm, and now see the first terminal of this resistance where it is joined. Now see this resistance, the one terminal of 3 resistance are joined at the point A, and other terminal, suppose that this point is X and this point is Y. So other terminal of this resistance is joined with the point X, and X is directly joined with the point B with the help of the conducting wire. So that is clear, the one terminal of this resistance is joined with the point A, another terminal is joined with the point B. So it is clear, the 3 ohm resistance is joined between the 2 points, point A and point B. And now see the second resistance. In the second resistance, one terminal of the second resistance is also joined with the point X, and X is joined with the point B. That is clear, one terminal of this resistance is also joined at the point B, and the next terminal, that is the second terminal, is joined with the point B, and you see the point B is directly connected with the point A. So the second resistance is also joined between the 2 points A and B. And now see the third resistance. One terminal of this resistance is also joined with the point Y, and Y is joined with the point A. So it is clear, the one terminal of this resistance is also joined with the point A, and the next point terminal of this same resistance is joined with the point B. So that is clear, no confusion. All the resistance, that is the 3 and 3 ohm, is joined between the points A and B in the parallel combination. Children, remember, in the parallel combination, if all the given resistance are joined in this way, the one terminal of all the given resistance is joined with the one point, and other terminal is joined with the another point, then the combination is known as parallel combination. And everyone knows the formula of the parallel combination. It is already explained in the previous lecture. So what is the formula of the parallel combination? 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3. And now using this formula and put this value R1, R2 and R3, all the given resistance are equal. So 1 by 3 plus 1 by 3 plus 1 by 3, and it is equal to 3 by 3. So resistance becomes 1 ohm. So in this way we have to find out the answer. The equivalent resistance across the point A and B, all the given resistance are joined in parallel. In the place of 3 ohm, if it is given the 4 ohm, so the procedure is same, and find out the answer, equivalent resistance between the point A and B. Yes, children, now see the next circuit diagram and find out the equivalent resistance between the points A and B. So now see the second diagram, and how can find the equivalent resistance across the point A and B. Children, across the point A and B in the given circuit diagram. So now we have to start from the point A. You see, first we analysis about the given resistance 5 ohm. Here the 5 ohm resistance is given to you in the circuit diagram, but one thing is here, the wire is directly connected across the resistance, and it is called the bypass. That means the current, suppose that current is flowing through the point A. Now it is follow the bypass. So in this case, no current is passes through this resistance. It is the useless. Okay. And now after that, it is the direction of current. This resistance is applicable. And now see the next resistance, 10 ohm. In the 10 ohm resistance, both terminal of the given resistance are joined with the single point. And if the 2 points of any resistance is joined with the single point, so it is also the useless resistance, no effect of the resistance in the combination of the resistance. Okay, so it is the useless, it is the short circuit, it is the short circuit. And now the current is passed through, it is the useless. And after that, the current is passed through the 2 ohm, and here the 2 ohm and 2 ohm both are joined in parallel. And what is the formula for the parallel combination? Everyone knows 1 by R equal to 1 by R1 plus 1 by R2. So 1 by 2 plus 1 by 2, it is equal to 1. So in the place of 2 and 2 ohm, we have to use the single resistance of 1 ohm resistance. And everyone knows about this circuit diagram. It is already discussed in the first question. There are the 3 ohm and 3 ohm resistance are joined in the parallel, and everyone knows what is the result across the 2 points. 3 and 3 ohm is resistance are joined in parallel, so resistance becomes 1 ohm. So in the place of all the 3 resistance, we have to use the only single resistance of 1 ohm. And children, now see how many resistances joined in the direction of the current. If the current is same in all the resistance in the direction of the flow of current, the current is same, then all the resistance are joined in series. So now see the 4 ohm, 2 ohm, 1 ohm and 1 ohm. How many resistance is connected in the series? 4, 2, 1 and 1. So what is the equivalent resistance? R equal to 4 plus 2 plus 1 plus 1. And it is equal to 4 plus 2 plus 1 plus 1. 4, 2, 6, 7 and 8. 8 ohm is the equivalent resistance across the point A and B. Yes, children. And now see the another type of questions. Now see the question, find out the equivalent resistance across the point A and B. And here it is the one, another resistance is also given. You see the circuit diagram. It is the 2 ohm and 2 ohm. It is also the 2 ohm resistance. And it is the 4 ohm resistance. It is 4 ohm. Suppose that one additional resistance is also connected across this resistance. It is 4 ohm. And find out the equivalent resistance across the point A and B in the given circuit diagram. Children, everyone remember, suppose that there are different boxes given in the circuit diagram. So first you will solve the small boxes, and after that you have to solve the big box. And how can find this one? You see, the first box is here given between the points x1 and x2. You see, between the point x1 and x2, 2 ohm and 2 ohm resistance both are joined in series. So there the 2 and 2 both are the equivalent resistance. 2 plus 2, it is the 4 ohm resistance. So in the place of 2 and 2 ohm resistance, it is equal to 4 ohm. And this 4 ohm resistance, the single resistance, is connected across the point x1 x2 with the 2 ohm resistance in parallel. So 4 ohm and 2 ohm both are joined in parallel. So now apply the formula for the parallel combination. 1 by R 1 equal to 1 by 4 plus 1 by 2, and it is equal to 4 here, 1 plus 2, 3 by 4, and R1 equal to 4 by 3 ohm. It is equal to 4 by 3 ohm. So in the place of all these resistance, we have to connect the single resistance of 4 by 3 ohm. So now see the change of this circuit diagram. One single resistance we have to use in this circuit diagram of 4 by 3 ohm. And after that, you see here the second box. Find out the equivalent resistance across the point x3 and x4. Both resistance are joined in parallel. That is the 4 ohm and 4 ohm. 1 by 4 plus 1 by 4. Everyone knows the parallel combination. Apply this formula. 1 by 4 plus 1 by 4. It is equal to 2 by 4. 1 by 2, and this is the reciprocal. So resistance becomes here 2 ohm. So in the place of 4 and 4 combination, we have to use the single resistance of the 2 ohm. So now change the shape of the circuit diagram. We have to utilize the single resistance in the place of combination of 4 and 4 ohm. The single resistance is 2 ohm. And now see the equivalent resistance across the point A and B. All the resistance in the direction of current, because the current is same in all the resistance. So the resistance is joined in the series. So what is the equivalent resistance? R equal to 2 plus 4 by 3 plus 2 plus 4. The first resistance 2 ohm, 4 by 3 ohm, it is 2 ohm and it is 4 ohm. And now see how can solve it here. 2 plus 2 plus 4. It is 8 plus 4 by 3. And now solve it. 3 8 24, 28 and by 3. 28 by 3 ohm is the equivalent resistance across the point A and B. And in this way, we have to solve the different type of the questions which is related with the resistance combination. And now see the another question. Children, if there are the three resistances given to you here, 2 ohm, 4 ohm, 6 ohm, there are the three resistance. And we have to introduce the one resistance in this way. So in the place of 2, 4, we have taken the simple examples here. Suppose that 3 ohm and here it is given the 6 ohm. It is the 3 ohm resistance. And now say the 3 ohm resistance, 3 ohm and 3 ohm. Find out the equivalent resistance across the point A and B. In the given circuit diagram, find out the equivalent resistance across the point A and B. But here the one additional resistance is given here 3 ohm and one is 3 ohm. It is the different type of the questions. And this question is based on the Wheatstone Bridge. Children, you see, this numerical is based on the concept of Wheatstone Bridge. Wheatstone Bridge. And now see how can open this circuit diagram. We take the intersection point here, where the wire is connected, x1 and x2. It is the junction x1 and x2. First we have to make this x1 and x2 vertical here. No problem. It is the different shape of this same circuit diagram. It is x1 and x2. And which resistance is joined between the x1 and x2 equivalent? It is the 6 ohm. So now we can write here the 6 ohm resistance. And you see the point which is lies left point here. The x1 is given there. So left point is given here A. So we have to put the point A here. And the right hand point is given to you B. A and B. And now see in this circuit diagram, which resistance is directly joined between the point A and X? Which resistance is joined directly between the point A and X? You see here and search in this given circuit diagram. Which resistance is joined between the A and X, X1 directly? It is the X1, it is A. So this resistance is joined directly between the point A and X1. So now we have to join the 3 ohm resistance between the points A and X1. And after that, you see the resistance between the A and X2. A and X2, which resistance is joined between A and X2 directly? You see here point A and it is X2. So directly resistance between A and X2 is this resistance 3 ohm, and now it is connected in this way 3 ohm. 3 ohm. And now see here the point X1 and B. X1 and B. Which resistance is directly connected in the above circuit diagram between X1 and B? You see, it is the point X1 and it is the point B. So this resistance 3 ohm is joined directly between the point X1B. And from this X2 and B, you search the resistance which is joined between the X2 and B. X2 and B, which resistance is connected? X2 and B. This 3 ohm resistance is joined directly here. So now the one another resistance is joined 3 ohm. Yes, children. So you see the shape of this circuit diagram, the new form of this resistance combination. This form is introduced by the Wheatstone. Wheatstone is the name of scientist, and according to this Wheatstone bridge concept, if the ratio of this resistance, if it is P and it is denoted by Q and it is denoted by R and it is denoted by S, there are the 4 resistances joined in this way according to the branch of the parallelogram or square in there, P, Q, R, S. So according to the Wheatstone bridge, what is the concept? If P by Q equal to R by S, if P by Q equal to R by S, then in this condition, no current is passes through the diagonal X1 and X2. If the ratio of P and Q and R and S both are equal, then no current is passes through the diagonal X1 and X2. Why? Because X1 and X2 both have a same potential, that is Vx1 equal to Vx2. And everyone knows no current is passes between the 2 points which have at the same potential. So no current is passed through the between X1 and X2. So it is the useless resistance. No use of this resistance according to the Wheatstone bridge, because you see the ratio 3 by 3 it is 1, 3 by 3 it is 1. It is clear? So no current is passed through the X1 and X2. So now after that we remove this resistance from the circuit, and now it is the very simple circuit. There are the 3 and 3 both are joined in series. So R equal to R1 plus R2, 3 plus 3 it is 6 ohm, and here the 3 and 3 both are joined in series, so it is 6 ohm, and one single resistance 6 ohm and 6 ohm both are joined in parallel between the points A and B. So now apply the combination formula, parallel combination. 1 by R dash equal to 1 by 6R plus 1 by 6R, it is equal to 2 by 6R in the form of R resistance, but it is given the 6 ohm resistance value. So directly you can put the value 1 by 6 plus 1 by 6, it is equal to 2 by 6, and now R dash equal to 6 by 2, answer is 3 ohm. And children, for the competition you have to remember, if in this type of shape or in this type of shape, if all the resistance is given the same value, that is the 3, or all the resistance is given 4, or all the resistance is given 6, if all the resistance is equal and circuit in this type in the form of Wheatstone bridge, then the equivalent resistance is always equal to the same value. If all the resistance is 3, the resistance is 3 ohm. If all the resistance have equal value 4 ohm, then the equivalent resistance is also 4 ohm. If all the resistance are given in 6 ohm in all the branches here, then the result is also 6 ohm. So children, now we have to discuss the different types of numerical in the next part of this video. So children, just you see the video, and after that you subscribe my channels and like it. Thank you to all of you.